What is up, guys? This is my latest build for a stereo amplifier. It's a lot better than the previous LM386 builds I made. You could check out those videos, but this one is really good because it's left, right, and center channel. And basically this is just the schematic. I have it built over there, but I'll just go over the schematic real quick. So pin 1 is basically the input, the non-inverting input. So that just goes from a capacitor as basically a DC filter. So there's this 10K potentiometer over here as well to basically control the gain of the audio. And then pin 2 is the non-inverting input, which feedbacks into the output. Pin 4. And then the pin 3 is just ground. Pin 4 is the output, and pin 5 is the positive, which I have hooked up to positive 12 volts. And the other part of the circuit is this 7805, just the regular linear voltage regulator that I'm using to power. I'm actually not using this chip anymore. I'm using a different chip, but this is just basically a VU meter, volume meter, just lights to indicate the sound. But this circuit is very similar to the one that I'm using, but I ended up not using this just for space constraints. And I'll go ahead and show you what it actually looks like. So this is just for one amplifier, one channel, but I built 3 channels. I built a left, a right, and a center. And to achieve that, for the left channel, I just built this. Right channel, I just hooked up the right channel to another one, so I built another copy of this. And then the center channel is a little bit different. The way I did it, there were 2 ways I thought of doing it. I was thinking of either using a summing amplifier, such as one with a 780, with a maybe an LM741, or I have this other IC over here that is a dual op amp IC. So this IC would have also worked for a voltage summing amplifier, so I could sum up the left and right into a center, but I decided to use mixer resistors. So I'll just draw it real quick what that would look like, what I did. So what I did was I basically, let's say you got left and you've got right. So what I did was I took 1K, and then I basically just bridged them over here, and that's what I got as the center, which is just something in between the left and the right. You're basically just averaging out the signals with this voltage divider. So that's what it looks like here. You can see this is the left channel. It has a potentiometer for controlled 10K potentiometer. Right channel is that IC, is the same, they're all the same IC except that's the 7805. And I forgot to mention this IC is the TDA 2003. It's a 10 watt per channel amplifier if you use 2 ohms, which is, I'll go into that next. That's the right channel potentiometer, and I have them set to basically the same. Also, the center channel, you can see the mixer resistors are pretty invisible to see. There's one of them. Left channel mix resistor, and then the right channel one is behind this potentiometer. I don't think you could see it. Oh, there it is. That 1K resistor. And then the 7805 drives this volume meter, power supply filter cap. There's actually 2 of those. There's that big one. Oh, there's a few. There's this ceramic ones as well. And I'll just show you the power supply I'm using. I'm using just an ATX power supply right there. So I'll turn it on and I'll show you that unlike the LM386, this one has nearly no noise. And by noise I mean like hissing on the power up, or you know what I mean. So basically that was caused by a ground loop, and to get rid of the ground loop, there's 2 things you can do. You could either use a resistor with 2 diodes in reverse of each other as a ground loop isolator, or you could do what I did, which I just broke off the ground prong on my power supply. So I'll show you that. So this is the power supply. I just broke the ground prong so it doesn't go into a ground loop with my computer or with this other power supply, which is powering this monitor for the Raspberry Pi or my other monitor. So I just broke off the ground prong so it doesn't go into a ground loop because I was kind of lazy to implement that isolator. So I'll just flip this switch. You can hear there's no noise at all. And it's plugged into my computer right now. It's super quiet. It's really, really loud. For 10 watts is pretty good. So the speakers I'm using are just generics. Two 4-ohm speakers in parallel to make it 2 ohms. Because this chip will be 10 watts only at 2 ohms. So same thing there. And then the center is just connected to this 3-ohm speaker. It's a Sony speaker. It's pretty good. And they're all connected with twisted pairs. I have a speaker terminal. I'll show you that. I think it's over here. It might not be. I don't know where I put it, but it was just kind of a hassle to use a speaker terminal when I could just twist them together. But I have them all just twisted together like that. Works out pretty good hidden behind my desk. And that's pretty much it. I might want to show you guys how the VU meter looks. Let me just power it back on. Pull out my PC. So I'm just tapping on the... I'm not going to play any music because you can't really determine how loud it is by... But yeah, it's pretty nice. So... Oh, my RetroPie turned on. Yeah, I started using a new monitor for my RetroPie instead of this crap. There it is. I got these NES controllers. I have a couple of new videos planned. I'm going to make one about my RetroPie. And another video I have planned is about this. Just a little sneak peek. Think you can guess what this is? Yeah. Pretty crazy. And I'll get back to you guys soon. I'll actually probably start making a video about this right now. So thank you so much for watching and have a good day.